Hello students, welcome to IMS GATE Academy. In the foundation course, I started network analysis. I did the theorems of Thevenin's, Norton's by using dependent and independent sources. In this session, I want to start superposition theorem. The basics of this theorem you can understand now. Basic problems I will do now. I will explain the theorem and I will do the number of problems. Understand now. Yes, we can enter into the subject now. Superposition theorem. Superposition theorem. But I am not going to give what is theorem here now. Just I will explain the theorem and I will do the problems based upon that. When we can apply superposition theorem? Whenever any network contains more than one source, maybe voltage source, maybe current source, or both, then you can apply this superposition theorem. The more than one source means that source must be an independent or voltage source, independent source or dependent source. I can say more than one independent source whenever you are having in the network, you are going to apply superposition theorem. Along with independent sources, you need to have, even you have dependent sources, you can apply only now. So, superposition theorem is applicable for the network which contains independent sources and also with dependent sources also. 100% we can apply only now. Understand the theorem. But I want to explain this theorem clearly now. Suppose there is a network in this form. There is a resistance of R1 and voltage source, otherwise even the current source also you may give. Current or voltage source acceptable. I connected one V1 voltage source. Here I connected one more resistance R2. I connected here now. And thereby Kushal, hi sir. Good afternoon Kushal. And also we got resistance R3. This is connected with one more source, V2. That may be voltage or current source, no problem. More than one source if you got, you can apply superposition theorem. Suppose you are asked to find out the current I. This current is required. Nikhil Gaurav, good evening sir. Good evening Nikhil sir. Yes, the network is given, thereby required current I. How we can determine this current? The students will say generally, sir, I will apply nodal analysis to find out the current. Yes, possible. I am not saying it is not applicable. Applicable. And also some students will say, sir, I will not apply the nodal analysis, sir, I will apply mesh analysis, sir. Yes, possible. That also applicable. One more method is nothing but superposition theorem also. Sir, why you are applying superposition? More than one source we got, then applicable. Understand my point now. But in this case, what you have to do, this circuit is to be redrawn in this way. By selecting individual sources, you find out the current I. I say, initially I selected voltage V1. I connected here resistance R1 and also connected with voltage source, that is a V1. Along with this, I connected resistance R2. This voltage source I short circuited now. Whenever you consider one source, the other source must be short circuited or open circuited. Short circuited means when you can short circuit, if you got any voltage source, you short circuit. If you got the current source, you can open circuit only now. Here I got the voltage source, so I want to short circuit. Wherever voltage source is given, there you must short circuit. The current passing through R2, I want I. Here I want to take current I1. You find I1 here. Find I1. Sir, how I have to find I1? Choice is yours. Choice is yours. Sir, I will apply the what nodal analysis. I will apply the mesh analysis. Any analysis you apply, you find the what now I1 here now. The second case, what you have to do, this voltage source you consider second voltage source. The first one is to be shorted. I say the first one is shorted here now. First voltage source is shorted. R2 I connected here. Resistance R2 I connected. And R3 is there. And also I wish to connect voltage source V2 here. This is V2 I have taken here now. From these, you try to find out by using this voltage source, you measure current across R2. I wish to take that as a I2 only now. By using the nodal or mesh or any one of the method, you find V2. In the problems, you will see what method I will apply here now. Find V2. Find I2, I say. Find I2. By means of selecting the individual sources, we got currents of I1 and I2. Finally, the net current I is required. Net current I is nothing but the summation of these two currents only. I1 plus I2 is nothing but the current which is passing through the R2 only now. That way we need to calculate current I. Not only the current, even if you want to find out the voltage across any resistor, you can use the same conditions only now. Suppose you are asked to find out the voltage across R2 by giving the what now more than one source, maybe 2 voltage sources or 3, 4, no problem. In that case also voltage we can find by selecting the individual sources only. This is the methodology to get the current or voltage. Understand my point now. The purpose of superposition theorem here to measure the current and voltage here now. Understand now. Now we can go to problems now. The first problem. Find the value of I. Find the value of I. I am asking to find I by using, but I will not ask the what superposition theorem. Find the value of I for the given network I am giving here now. For the given network. The network is given like this. 6 ohm resistor is connected here. There is a 6 ohm resistor and connected with 18 volts battery. 18 volts. And here connected with 3 ohm resistor. This is 3 ohm resistor. And here connected one 10 ohm resistor. 10 ohms here connected. And also connected with 6 amperes. Current source is connected 6 amperes. This is the given problem. The current across, what element is required? Current across 3 ohms it is given I. Is asking to measure current I. Find the value of I for the given network only now. I will check the elements what they are given. 18 volts, 6 ohms, 3 ohm, I, 10 ohms and 6 ampere. Yes, that is the given problem. But in the problem it is not specified by using the Thevenin's or by using the Norton's or by using the superposition theorem, not specified. By using the nodal or by using the mesh, you will not specify. But there you can apply any method. I want to apply what now? Superposition theorem. Sir, why you are applying? I got here now more than one source. One is a voltage source, one is a current source. Now, initially what I did, I selected 18 volts. One source I will consider. at first. What source? What source? I will consider voltage source I have taken here now. I will draw the network in this way. The 6 ohm resistor I got. This is connected with a battery, 18 volts. And here connected with 3 ohm resistance. This is 3 ohm resistance. And here, this current source here, the second one is the current source. Wherever the current source you got, that must be open circuited, I said already now. The current source I removed. When the current source is open circuited, the 10 ohm will not have any effect because it is an open circuit only now. It doesn't have any effect only now. So current through this across 3 ohms, I wish to take it as I1 initially. But this is I1 means even this also I1, it is a single loop only now. Even this also I1 itself now. By using Ohm's law, I can measure I1. Directly you can measure. So I1 equal to, I can write 18 by voltage by resistance 6 plus 3, 9. 2 amperes of current is passing here now. So it doesn't flow any current this side. It is an open circuit only possible. Finally, we got 2 amperes in the first case. Now I wish to select the second case. In the second case, this voltage source I want to short circuit. That current source I want to consider as it is. So I will do, please watch. I have taken 6 ohm resistance here. There is a 6 ohm resistance. The source, voltage source is shorted here. And still I got 3 ohms this side. I got 3 ohms this side. 3 ohm resistor I got. This current I want to denote a symbol I2 here. And there is a resistor and also a current source in the problem. What current source is given in the problem? You check it now. The current source is 6 amperes. 6 amperes. And resistance is given 10 ohms only now. Is it right? 6 shorted, 3 ohm, 10 and 6. Exactly correct now. But in this case, we need to calculate I2 by selecting this current source. But according to current divider formula, we can find out the I2. Current divider means what I can do? The current I2 is required in this direction, top to bottom. But this current will pass in reverse direction only now. 6 amperes. From 6 amperes, some current will divert this side. That current is in reverse. Whenever this supply current is opposite to the I2, I can take a sign of minus only here now. So I2 is calculated with a sign minus. I say I2 equal to what? According to current divider formula, minus of, because the current is in reverse. 6 into opposite resistance, 6 by 6 plus 3, 9 I can put here now. And I can cancel 3 2s, 3 3s I can cancel it. 3 2s I can cancel. Finally, I2 equal to how much I can get? Minus 4 amperes I am getting it. What about the net current I? The current passing through the 3 ohms is nothing but the summation of these two currents only. I1 plus I2 I can put. What I1 I am getting before? I1 I am getting 2 amperes now. Yes, I got I1 equal to 2 amperes. What about I2? I2 is nothing but the minus 4 amperes. 2 minus 4 minus 2 amperes of current is passing through the what now? 3 ohms we can say the now. That is the net current is possible here now. This is the answer. In this way, we can do the problem by using superposition theorem. So I would like to do the number of questions by using this method. I will give the problems from by using the dependent and independent sources also. Both I will give. Now the first problem I have done with what now? Independent sources. And second one I will do with what now? Independent and dependent also. You check, you watch now. The next question I will give. The second problem here given is find V naught. Find Vx, sorry, not V naught, Vx. Find Vx for the given network. For the given network. For the given network. The network is given like this. There is 1 ohm resistor. The voltage across this 1 ohm is given with polarity like this, minus and plus. This voltage is given Vx. Voltage across 1 ohm is nothing but the Vx. Polarity also given. Here given 1 volt battery. And also given one current source this side. This is the current source is given. That current source is given 1 ampere. This is 1 ampere. That current source is given 1 ampere. And the side it is connected with one resistor. Its value is nothing but 1 ohm. And one dependent source is given. This is the voltage source, plus minus Vx by 2. Yes, this is the given problem. I'll check the values once again. 1 volt, 1 ohm, and also Vx current is 1 ampere. This is a 1 ohm, Vx by 2. Yes, this is the given problem. But this problem you got with what? Independent sources of 2 we are having in the problem, and also one dependent source is given. But don't bother about the dependent source. You think about how many number of independent sources are given. Thereby given 2 independent sources now. So I can draw 2 circuits. Then after I can determine the what now? Required value of Vx only now. How we can determine the required value of Vx watts? I selected initially this 1 voltage. This current source I want to open circuit only now. I say I wish to select this voltage source. This is 1 ohm. But whenever you are taking the what now, any individual sources, initially you must take this as a Vx1 otherwise. By using this second source Vx2 you will calculate. What is total Vx? Vx1 plus Vx2 only now as per superposition theorem. I can select this as a voltage source. Here I got 1 volt. This current source is open circuited now. One is to be open circuited. And I got 1 ohm resistance this side. This is 1 ohm. There is a dependent source. That dependent source I can put as plus minus Vx1 by 2. I can put here now. Here the polarity is given plus and minus only now. How you can find Vx1 is more important. What I will do, because of this voltage source, it is going to flow some current. That current I have taken I. This current is I. The same current is going to flow this side. Same current will flow this side. So finally it is a series circuit only now. I can apply the KVL in this direction. Whenever KVL is applied, you can determine Vx1. You watch it now. Voltage, supply voltage equal to sum of the drops. 1 into Vx1, 1 into I, 1 into I means Vx1 only now. Voltage across this Vx1 plus Vx1 I got. When I go this side, some drop, 1 into I, 1 into I. When I go down, plus Vx1 by 2, plus Vx1 by 2 I got. As once again I am repeating, supply voltage equal to sum of the drops. Voltage across this Vx1. When you go this side, current into resistance, this is the drop. This voltage drop is, this voltage is Vx1 by 2 only now. But to determine the voltage of Vx1, I value is more important. How I can get that I? I is nothing but current across 1 ohm also I can write. It's not a mistake. Sir, why you are taking current across? This only means voltage also I know, current also I know. So I can be written Vx1 by 1. Vx1 by 1, that is equal to Vx1 only now. So wherever you are finding I, there you can put directly Vx1. Then you can determine Vx1. I say 1 equal to, I can write Vx1, I can put as it is. I is nothing but Vx1. 1 into Vx1, same Vx1. Here I got Vx2. Finally, I got in this way, Vx1. This is Vx1 by 2 I got. Now I want to simplify by taking LCM. LCM is a 2. 2 into 1, 2 this side. This side I can get 2Vx plus 2, 1 plus 1, 2. Vx1, Vx1, 2Vx1, 2 into 2, 4. 4Vx1 plus Vx1 I can write. Finally, I am getting 5Vx1 equal to 5Vx1 equal to 2. Vx1 is nothing but 2 by 5. 0.4 I can get here now. 0.4 voltage I got. So, by selecting this 1 voltage battery, I started the work and I got Vx1 as 0.4 voltage only now. Now what I can do, this voltage source I want to short circuit, I will consider this current source. Then I want to measure what is Vx2. Now you please watch how I will do, how I will find Vx2. Here I got 1 ohm resistance. Here the voltage source we are having that I shorted, catch it now. This voltage source I shorted. Voltage drop is Vx2 I can put here now. Minus and plus, this voltage is Vx2. We got here one current source. That current source is given here 1 ampere. Yes, I will put this as a 1 ampere. And also we got this side. What we are having this side? 1 ohm. This is 1 ohm. This is 1 ohm. And also we got one dependent source. Plus minus. That voltage is given as Vx by 2. I will put Vx2 by 2, I will put directly. Vx2 by 2. Yes, such a way we can form the circuit. 1 ohm, yes. And also this 1 ohm Vx2, it is taken exactly correct. 1 ampere I have taken, 1 ohm is taken, Vx2 by 2, exactly correct now. But we need to determine Vx2 again. What way we can find Vx2? Any method, your choice. I want to apply nodal analysis. By using this nodal analysis, we can determine the Vx2 value. What is this node voltage? Voltage across the resistance is directly given minus Vx2. Sign is given minus Vx2 voltage across this. So this node voltage also minus Vx2. Same voltage minus Vx2 we got this side. As per nodal I can find this Vx2. This current plus summation of away from the node you put it now. This current plus this current equal to 0 we can put. I can find current across this minus Vx2 by 1 this side. Minus Vx2 by 1 we got current this side. This current is directly given 1 ampere is this direction. I want in this direction. So minus 1 I can put this side. What current is passing this side? This current is nothing but minus Vx2 current across 1 ohm is nothing but the current across this side. Minus Vx2 I will write minus Vx2 minus what voltage? Vx2 by 2. Vx2 by 2 divide by 1 ohm. Voltage by currents. Summation of all these currents equal to 0. Such a way I can form an equation. Catch my point. This current is minus Vx2 by 1. Yes, I have taken. This current is minus 1. This current is minus Vx2 by 2 divided by 1 only now. That way we have taken. Simplify and find Vx2 only now. How we can simplify? Here minus Vx2 I got, that I can put as is. This 1 I can take that side. Minus Vx2, 2 minus 3 Vx2 I can get now. Minus 3 Vx2 by 2. This minus 1 when comes to this side plus 1 it is possible. On simplification minus 5Vx2, 2 and 3. 5Vx2 equal to 2 it is possible. Finally what Vx2 I can get here? Minus 2 by 5. Minus 2 by 5 is nothing but minus 0.4 voltage we are getting. Yes, we got. By using the individual sources, we got the what now? Vx1 and Vx2. And finally, what is the Vx means? Vx1 plus Vx2 as per the superposition theorem. I say the value of Vx I can find with the summation of these two voltages only now. Vx1 plus Vx2 I can put directly. What is the Vx1 we got already? Vx1 we got as a 0.4 voltage here. Yes, we can put 0.4 volts. What about the Vx2? That is nothing but minus 0.4 we got. Finally, what is the value? 0 voltage is possible. So, Vx is nothing but 0.4 voltage we can say in this problem only now. Thank you, Nikhil Gaurav. Thank you. Excellent question. Yes, for your comments, I am with more satisfaction only now. Yes, I want to give you one more question here now. Now, the first question I have done with what? Independent source. The second question I have done with what now? Dependent and independent source only now. Now, again, I want to give the what now? One, by using the independent sources, I wish to give one more question now. It is a simple question only, but how to apply the superposition theorem, just we can understand by these problems only now. Understand my point now? Yes, I will start this question now. One more question I will start. It's a very simple question. Find I. I'm asking to find I for the given network. For the given network. For the given network. What network is given in this question? You please watch. Here given one 3 volts battery. 3 volts battery is connected here now. And this is connected parallel to 1 ohm, 1 resistor. Its value is given 4 ohms. It's given 4 ohms. And also given 0.25 amperes of current. Here connected with one current source. This is 0.25 amperes. It's a very simple question. But is asking to measure these currents. What is I? If such a simple question is given, nobody is going to apply the superposition theorem generally. Sir, why they won't apply the superposition theorem, sir? This can be done by using the superposition theorem, and also it can be done by what now? Just by applying the what now? Ohm's law also we can do also. You know, Ohm's law means current across these 4 ohms you measure. 3 voltage. So just I will explain initially directly. Directly means what you will do? 3 volts are there, means 3 you will put now. These two are in parallel. Voltage across 4 ohms is nothing but the 3 voltage only. And a voltage by resistance can give the what now? Voltage by resistance it can give the what now? Current only now. 3 by 4, 0.75 or something it comes, 0.75. This current is 0.75, this current is a 0.25. I equal to what? 0.75 plus 0.25 is nothing but 1 ampere. Directly we can write now. That is the direct method only now. But to understand well about the superposition theorem, this problem also I wish to do by using the superposition theorem. Even if you know the other methods only now, just to know only now, understand now. How I will do by using superposition, sir. But some students used to think, sir, superposition theorem means we need to draw the two circuits, we need to calculate the value of current or voltage, sir. By using the nodal, what now? Just by using the one circuit I can complete, sir. Yes, possible also. If you are comfortable with the what a nodal or mesh, you can do. And this is nothing but one more method to determine the what now? Current or voltage only now. But I am doing the what? I am using the superposition theorem here. I selected these 3 voltage for example. I connected these 3 voltage. This current source I open circuited now. Whenever I open circuited this current source, I can get only 4 ohms only this side. This is 4 ohms. The current which is passing through this side I have taken as a I1. This current source is open circuited here now. Directly what now? Ohm's law I will apply here now. I can get the I1 directly. What is I1? If I ask, anybody can say 3 by 4 sir. voltage by resistance only. 3 by 4 means it can give the 0.75. 0.75 amperes of current it can give. Directly you can get now. Just to know how to apply superposition theorem here now by using the simple problem only now. Now what I did now, this voltage source I shorted, this current source I considered only now. I wish to take in this way. I short circuited this side and I connected with 4 ohm resistance this side. There is a 4 ohm resistance this side. And I wish to consider this current source only now. That current source is nothing but 0.25 amperes only. I am in need of current across this branch. This is I2 I want to take only now. But in this case, how I can get I2, sir? Yes, 0.25 amperes will go this side. It will not divert across the 4 ohms. Why, sir? This side we got this short circuit this side. At the time, what happened? There is no resistance also. Directly, what now shorted this current, same 0.25 will go this side. Same 0.25 will try to pass this side also. That much current. Finally, I2 equal to 0.25. Yes, I can put I2 equal to 0.25 amperes only. And finally, what is the net current I? By using superposition theorem, the summation of two currents are made, we can get the I1 plus I2 only. I1 is nothing but 0.75 and the second one is nothing but 0.25. The net current which is passing through this circuit is nothing but net current which is passing from the what now source is nothing but 1 ampere only possible. Yes, this is the answer. In that way, we can do the question. It's a very simple question, and also by using the simple circuit, I gave it now, just to know idea about the superposition theorem. Now, I want to give one more question based upon the superposition theorem. But here I will give the what now dependent and independent sources. Both I will give the now. Then you try to do without my help. Yes, you make an effort to get answer for this question. The problem is given like this. Find Ix, is asking to find Ix. Find Ix. Find Ix. And here connected with a source voltage source 10 volts connected here. Yes, this is with given with 10 volts. And also connected this side 2 ohm resistance. 2 ohm resistance this side connected now. And current of 3 amperes passing this side. This is given current source like this. 3 amperes it is given. And 1 ohm resistance is connected this side. There is 1 ohm resistance. And also connected one dependent source. Here connected with a dependent source. That source is nothing but the voltage source. It is given plus minus. This is 2Ix. 2Ix. Sir, what is that Ix, sir? The Ix is nothing but current across this 2 ohm. It is given. Current across this 2 ohm is nothing but Ix only. Is asking to measure Ix from the given problem only. This is the given problem. How we can do, how we can calculate. But you need to watch this problem. This problem I said already, this problem can also be done by any other techniques also, nodal or mesh, so you can apply to find. Here I wish to apply superposition theorem. Why, sir? How many number of independent sources are given? You check it first. Don't bother about the dependent sources now. How many number of independent sources? Yes, we got the 2 independent sources now. But don't think the circuit must be with what now? 2 independent sources only. More than 2 also given means you can apply superposition theorem. Even 3 or 4 or whatever the number of what now sources are given, you can apply. Understand now. The more than one source I got, I can apply the what now? Superposition theorem. In this case, initially I selected 10 volts. This voltage source I considered. I wish to take this voltage source, 10 volts I have taken. Solution I will put. I selected this 10 volts. This is 10 volts. Unconnected with a 2 ohm resistance this side. There is a 2 ohm resistor. And this current source must be open circuited. Now, I would like to remove this current source. By selecting the individual sources, we need to tackle the problem only now. Here given 1 ohm resistor. Along with 1 ohm resistor, there is a dependent source. I can connect the dependent source also. That source is given here now, plus minus 2 Ix it is given. Ix1 I will put here now, because the first initial circuit I have taken now. The current across these 2 ohms, I wish to take it as Ix1. I want to take here now. Yes, I am in need of this Ix1 only now. I am in need of this Ix1. How we can find this Ix1? Just by applying the KVL, we can find Ix1. Just apply the KVL and get the value only now. How to apply KVL, sir? Yes, you watch it now. Directly, we can apply KVL in this direction. Supply voltage equal to sum of the drops. What current is passing? Ix1. Throughout the circuit, Ix1 will flow. I can write 10 volts equal to the drop across this 2 into Ix1. What current is passing across 1 ohm? Same Ix1 will pass. So we can write 1 into Ix1 here also. Plus 2 Ix1 I can put here now. 2 into Ix1 I can put directly now. Yes, I applied the KVL. Now I wish to measure Ix1. So 10 equal to 2 plus 1, 3, 3 plus 2, 5 Ix1 I am getting. So finally, what is Ix1 here? 10 by 5 is nothing but 2 amperes of current is passing this side. Yes, we are getting the 2 amperes only now. 2 amperes of current is passing because of this source. Now I will short circuit this voltage source and I will consider this 3 amperes. Then I want to measure what is Ix2. Then summation of those two currents will give the what no required current now. Yes, in the next case, this 10 volts I short circuited here now. This 10 volts I short circuited now. And I got a resistance here now. That resistance is nothing but how much? 2 ohms here now. Yes, I can write this a 2 ohm resistor. The current passing through these 2 ohms, I wish to take it as Ix2. There is one current source. That current source is given as 3 amperes top. This current is given 3 amperes. I can put 3 amperes of the current only now. And also connected here, what's connected here now? 1 ohm this side. Yes, I will connect the 1 ohm this side. This is 1 ohm. And here we got the dependent source. We got a dependent source. 1 ohm. What dependent source is given? 2 Ix. Yes, we can write 2 Ix. 2 into Ix2 I can write here now. Such a way we got. We can check once again these values. Yes, it is a 2 ohm and also 1 ohm and 2 Ix and also this 3 amperes is given. Yes, exactly correct now. So how we can do this? What way we can do this question now? We are in need of Ix2. Directly KVL only here. How directly we can apply the KVL? But if I know this current, I can apply the KVL in this case. This current is nothing but this side we are getting Ix2. This current is nothing but the 3 amperes. Net current this side is nothing but 3 plus Ix2 I can write. 3 plus Ix2 I got. And I wish to go in this path. Which path? This path we can select directly. Yes, I will select the path in this direction. KVL I want to apply in this direction. If I apply the KVL in this direction, directly Ix2 I can measure only now. Yes, we can try. 2 into Ix2. Yes, sorry. 2 into Ix2 I can put here now. 2 into Ix2. When I go this side, 1 into 3 plus Ix2. 1 into 3 plus Ix2 I can get here now. And when I go this side, plus 2 Ix2 I can get now. Plus 2 Ix2. I can write, this is 2 Ix2. 2 Ix2. That equal to 0 only possible. Catch my point. This current is a 3 amperes, this current is a Ix2, this net current is nothing but 3 plus Ix2. Just I applied the KVL. 2 into Ix2, voltage drop across this. Voltage across this 1 into 3 plus Ix2. This side plus 2 Ix2 I got. Then I can determine the value of Ix2. This is a 2 I can take, and also what I can get now, Ix2, this is Ix2, 2 plus 2, 4, 4 plus 1, 5 Ix2 I can get now. 5 Ix2. This 3 can be taken this side, minus 3 I can get this side. So Ix2 is nothing but minus 3 by 5 I can get. Minus 0.6 amperes of current we can get only now. Minus 0.6 we are getting now. Minus 0.6 amperes of current is possible now. We want the net current. What is the net current? Ix2 I want. According to superposition theorem, Ix1 plus Ix2 is nothing but net current only. What is Ix1? You check it, already given. Ix1 is a 2 amperes positive, 2 amperes. Ix2 is nothing but the minus 0.6. Finally, I can get 1.4 amperes of current is passing. That is the net current possible. That way we can do the question right now. I hope students followed this question. And one more question I will give. One more problem I want to give in your hand only now. And you try to tackle now. Understand? But I am giving the simple questions here now. In the foundation course, we are going to find the simple questions only now. We need to understand how the theorem is to be applied only now. That is why the number of problems I have done in the Thevenins, number of problems I have done in the Nordens, and also I am doing the number of problems by using the superposition theorem also. In this class, we can spend the time only for the superposition theorem. In the next class, we can see the maximum power transfer theorem also. Now, understand now. By using the dependent and independent sources, I will do the now. Yes, we can go to next problem. Yes, this problem is given like this now. Find current through find current through 3 ohm resistor. 3 ohm resistor is asking current through the 3 ohm resistor. And here the 2 voltage sources are given. Here connected with one battery. This is with 20 volts. Once the students having the command to do the once you got the command on the subject, means you can do any sort of problem. First you need to do the simple problems of the maximum only. Then after you can enter into the tough problems also. Understand now. 20 volts, and here given 5 ohm resistance, and here given 3 ohm resistor. This is 3 ohm resistor. The current passing through the 3 ohm is given I. Here connected with 6 ohm resistor, 6 ohms, and also connected with 40 volts. Here connected with 40 volts. Shortly I will give number of branches also. I will increase the number of branches. You will see the big problems also now. Yes, find current through the 3 ohm is asking. 20 voltage is given, 5 ohms given, 3 ohms are given, and 6 ohms and 40 volts only now. Current through 3 ohms required. Yes, can you try this question without my help? Without my help, can you complete this question? Anybody? Yes, you watch how I will do this question. But here the more than one source we got here now. This problem also with more than one source only now. What are those sources are given? Both are voltage sources only here now. Both are voltage sources only now. Initially, I selected this voltage source and next voltage source must be shorted because we don't have any dependent source now. We got only independent sources in this problem only now. So what I say, in this problem directly I can take, I will consider this voltage source. This is nothing but 20 volts. Here connected with a 5 ohm resistor. Here connected with 5 ohm resistor. And there is one 3 ohm resistance this side. This is 3 ohm resistance. The current passing through this side I have taken as a I1. And 6 ohm resistor I have taken as it is. The second voltage source I shorted. I shorted such a way only now. But this current I1 can be calculated by different ways also. By using the nodal analysis we can do. By using nodal analysis means this node voltage we can take V. This current plus this current plus this current you measure. Current I1 equal to voltage by 3 ohm. That is one more method. One method. The second method means directly we can take the Maxwell's loop method otherwise now. According to Maxwell's, what is this current and this current, difference of these currents will give the I1 itself now. So that also I don't want you do by different way means we can do also. You find out the net current which is passing this side. This current we can assume Ix or something for example. Because of the supply some current will pass, that current is nothing but Ix I have taken, I1 is nothing but I1 I can determine by using the current divider formula. Once I got the current of Ix, I can apply the current divider formula. I can measure the I1 only now. But how to get IXR? The 6 ohms and 3 ohms are in parallel. 6 and 3 are in parallel. And series to 5 ohms only now. What I say, this value is nothing but, Ix is nothing but voltage by 20 volts divided by, these two are in parallel and series to this 6 into 3, 18 divided by 6 plus 3, 9. This I simplify. And series to 5 ohms plus 5, I can put directly, plus 5. 9 2 times I can cancel here now. And finally, I got 20 by 7 I got. 20 by 7 I got. We can take this as a Ix value I want to get. This 20 by 7 is nothing but 2.857. 2.857 amperes of current is passing. 2.857 amperes of current is passing. This is Ix. By using this Ix, I want to measure I1. I1 is nothing but according to current divider formula, I can get Ix1. Ix1 equal to what? Ix into, I can write Ix is 2.857 into, according to current divider formula, opposite resistor divided by this plus this, 3 plus 6, 9. 3 plus 6 I can put here now. But use the calculator and you will get Ix as, not Ix, I1 here. Is it Ix already we got? This is I1 I can say. This is nothing but I1 we are finding. We are finding the I1 value. So I1 equal to, I say, according to current divider, Ix into 2.857 into opposite resistance by 3 plus 6. I applied this now. If you are using the calculator, its value comes as, its value will be 1.904. 1.904 amperes of current is passing through this one. That way we can find the I1 itself now. In the same way, I want to find the I2 value. But I2 value, that means I2, but I1 I got this I2. This voltage source I shorted here now. Yes, we can short this voltage source. There is a resistance this side. That resistance is nothing but 5 ohms. This is 5 ohms. This is nothing but 3 ohm resistor given in the problem. This is 3 ohm resistor. And also connected with 6 ohm and 40 volts. 6 ohms and 40 volts. This is 6 ohm. This is the 40 volts, I can say. Yes, such a way network is given. Which current is required? Current passing through the 3 ohms required. Current passing through the 3 ohms, I can put as a what now? I2 only here now. I'll check the values once again. These are 5 ohm and 3 ohms and 6 ohms and also 40 volts only. Exactly correct now. How you can determine I2? Just like a last one. This net current you measure. This is IY. We can put clearly now. Once you got the IY value, current divider formula, you can apply directly. How you can measure the IY value? Yes, we can find in this way. I suffix Y is required here. Voltage by total resistance. Total voltage is nothing but the 40 volts. Divide by total resistance means 5 and 3 are in parallel. 5 into 3, 15 by 5 plus 3, 8. Plus what? It is series to 6 ohms only. Plus 6 I can put now. Then I can measure what is IY here now. The IY value will be here now 5.0. IY value is taken 40 by, yes, 5.07, 5.079 mostly possible. That much amount of the current you can get only now. If you are using the calculator 40 into 8, it goes 15 plus 6 into 8. You simplify, you will get that value only now. The finally, we are in need of what now? But IY we got now, this is IY. But I want I2 value only now. By using this IY, I can determine the I2. According to current divider formula, IY is nothing but the 5.079 into opposite resistor. Opposite resistance means 5 divided by 5 plus 3. I can write now 5 plus 3. And finally, I can find the I2 value only now. That I2 value comes as 3.17. It comes mostly 3.17. 3.17 amperes of current is mostly 174. It comes mostly 174 is mostly possible. But what about the net current of I? Net current of I is nothing but I1 plus I2 only now. According to superposition theorem, we can find I1 plus I2 only. What I1 you are getting here now? Already we got I1 as a what now? 1.904. 1.904. What about I2? I2 is nothing but 3.174. 3.174. Finally, net current is nothing but, the net current we got is nothing but 5.078. 5.078 amperes of current is passing now. That much amount of the current is passing. By using this superposition theorem, we have done this problem also. Understand that? I think every student might have followed this. But I said in today's session, you can find only problems on superposition theorem only. And I would like to give you one more question. You please try to tackle without my help. Without my help only now. But I will give you what now branches of one more, 2 branches or 2 loops I gave it. Now third loop also I will include. You try to tackle this question. Just we can extend the what now? Number of loops in the problem. But is asking to find I. Find I. Find I. In the circuit shown below. In the circuit shown below. In the circuit shown below. But this is given 75 volts here connected with a 75 volts source. Voltage source is connected here. And this side 5 ohm resistance is connected here now. This is a 5 ohm resistance. And this side 20 ohm resistance is connected. 20 ohm resistance. This side one more 5 ohm resistance is connected. This is 5 ohm. This is a 12 ohm resistance connected this side. This is 12 ohm resistance. And also connected with one 4 ohm resistance. This is 4 ohm. And connected with one more source here now, or one more battery is connected this side. Its value is nothing but 64 volts. This is the given problem. Is asking to measure this current. This current is given I. This current is given I. Yes, you can start doing this question. I will check the values once again. 75 and 5 ohms and 20 ohms and 5 ohms and 12 ohms and 4 ohms and 64 volts. Yes, exactly correct now. You can start your works to get the value. What way we can find? But in the problem it is not given. By using the superposition theorem, you find out the current not given. We need to identify is it applicable superposition theorem or not. When you want to apply the superposition theorem, the circuit must be given with a linear elements only now. All are linear elements only now. Resistance and source all are linear only here now. But in the linear circuit, what we can do here now, current I required means initially we can select this 75 volts and second voltage source must be shorted. Then we have to determine the current of I1. In the same way, this voltage source is short circuit and consider the 64 voltage and you find out the current of I2. The summation of these two currents will give the the net current which is required to you instead. Yes, we can start the work to get answer now. How we can do this question? I wish to select I want to take the solution here now. In this case, initially I selected this voltage source. Here I got 75 volts. This is 75 volts. And here I got 5 ohm resistance. This is 5 ohm. Here connected with a 20 ohm resistor. This is with 20 ohms. This side connected with 5 ohm resistance. This side 12 ohm is connected. This is 12 ohm. Here I got the 4 ohm resistance. This voltage source must be shorted only now. This must be shorted. 12, 4, 5 and 20 and 5, 75. Yes, that's given. If any student feels, sir, I will not apply the superposition theorem, sir, directly I will apply the Maxwell's loop method. This I1, this I2 and I3, sir. 3 loop currents I will take. I2 is nothing but I, sir. Yes, allowed. 3 loop currents to take it. By solving those 3 equations, we can get the current I. I2 you can determine easily. Sir, I don't want that method, sir. Yes, you can use one more way also. You select the node voltages. This is V1, this is V2 node voltages now. If you have taken V1 means this current plus this current plus this current equal to 0. Summation of these 3 currents equal to 0. You will get the one equation in terms of V1 and V2. Again, you select this node, this current plus this current plus this current you take it now. One more equation you can form in terms of V1 and V2. By solving those 2 questions, you can get the solution only now. Yes, that way we can do only now. Catching my point now. By selecting the nodal analysis we can do. By using the mesh analysis also we can do. But as we got the the circuit with more than one source, we want to apply the superposition theorem also. I selected here now superposition theorem only now. The selection of the method is your choice only. Understand my point now. Yes, in this case, how I can measure this current I? This current I want to take it as I1 only. But already I have done the 2 questions now. What I did then now, by simplifying the networks, net current I calculated now. The total current I calculated now. By using the current divider formula, I calculated the required current only now. Even in this problem also, I want to apply the same condition only now. How I can apply the same condition? I wish to find the current from the supply. That current I want to take it as Ix here now. Once I got the Ix, I can apply the I can find the current I1 only now. Sir, how I can simplify these networks, sir? Yes, we can simplify in this way. How these two are now? These two are in parallel. Whenever these two are in parallel, I can measure the resistance like this now. 4 into 12 I'm simplifying like this now, by 4 plus 12, 16. Here I can cancel 4, 4 times I can cancel. This 4 means it is a 4, 3 times I can cancel. I'm getting finally 3 ohms only here now. Yes, by means of what now simplifying these two, I got a 3 ohm resistor only now. But once I got a 3 ohm means I will connect this circuit, I can redraw in this way. I connected this voltage as it is, that is nothing but the 75 volts. And here I connected with a 5 ohm resistance that must be placed as it is only now. This 5 ohm I want to connect as it is. Here I got the 20 ohm resistor, I will connect as it is. Here I got the 5 ohm resistance, that 5 ohms I will connect as it is. When simplified these two resistors, I got only 3 ohms only now. Yes, this is the simplified form of the network, I can say. This is the simplified form of the network. In this case, this current I want, that current is nothing but I1 only now. Current across 5 ohm or current across 3 ohm is the same only now because both are in series only now. Yes, we can try for this current at first. This current I wish to find at first. How I can find this current? These two are in series and parallel to 20 and series to 5 ohms only. I say the current Ix I can determine the current of Ix voltage by just Ohm's law only. Voltage is nothing but the 75 volts divide by the total resistance. What total resistance we got here now? 5 and 3 are in series 8 parallel to 20. 8 into 20 I can write 8 into 20 divide by 20 plus 8, 28 I can get here now. And series to the what? And series to the what now? 5 ohm resistance one, that 5 ohm I will connect directly now. This is 5 ohm. Voltage by total resistance. These two are in series and parallel to this and series to this. If you are using the calculator, its value will be 7 amperes it comes. If you are using the calculator, it comes as a 7 amperes only now. On simplification, it comes as 7 amperes now mostly. Yes, we got the Ix. By using this Ix, I can measure the I1. How I can measure I1? I1 is nothing but current across 5 ohm. That current only, this I1. According to the current divider formula, Ix into Ix equal to 7 amperes into opposite resistance. Opposite to this 5 plus 3 is nothing but 20 ohms here now. 20 by, what I can write? 20 by summation of all the resistors. 20 plus 5 plus 3, 8. 28 I will get now. 28. That's my point. 20 plus 5 plus 3. It becomes a 28 only. Finally, I1 value will be 5 amperes possibles. This current comes as a 5 amperes only now. By selecting the what now? The source of this 75 volts, I got a 5 amperes only. The same work is applicable for what? For this voltage source also. Now the second source I want to consider. This voltage source I will short this with 5 ohms this side. This is shorted and 5 ohms I connected here. This I connected this side. This side 20 ohms. This side I got a 20 ohm resistor. I will connect as it is. This is a 20 ohm. And this side it is connected with a 5 ohms, no doubt. This is I2 I can put here now. This current is I2. Yes, so check 5 ohms I2. This is a 12 and 4. This is a 12. And the resistor is nothing but the 12 and what value given? 4 ohms with 64. 4 ohms with 64 volts this side. Yes, we got like this. Question only now. So other source I shorted, this source I shorted, that voltage source I considered. I will check the values correct or wrong this now. Here what we got? 64 volts this side, 4 ohms, correct, 12 ohms, correct, 5 ohms, it is okay, and 20 ohms and 5 ohms, it is perfect only now. Yes, we can start the work now. How we can do this one? The same as last one only now. You simplify like this now. But I can simplify the network this side. Then this net current I want to determine. My aim is to determine this net current. This is IY. Once I got the net current of IY, I can determine the I2 only now. These 5 and 20 are in parallel. I can write like this now. 5, this resistance I simplified. 5 and 20 are in parallel. 5 into 20 by 5 plus 20, 25 I can get now. 5, 5 5s, 5, 5 4s. Finally, we are getting the 4 ohms only. 4 ohms we are getting. So, by simplifying this, I got a 4 ohm only now. I say I got here 4 ohm resistance, and this side I got as a 5 ohm resistance. This side I got as a 12 ohm resistance. This is 12 ohm resistance. And also I got this side 4 ohm resistance. And I got here now 64 volts. This side, this is 64 volts only we got. We are in need of this current. This current is nothing but I2 only now. Current across this 5 ohm is required. Once we got that current I2, we can determine the net current only here now. The 4 ohms and 5 ohms. The first you measure this IY. Once you got this IY, you can determine the I2 by using the current divider formula only now. How I can get now? So I can write this 4 and 5 is a 9 series, 9 and 12 parallel, 9 and 12 parallel. I want to write IY like this now. Supply voltage 64, no doubt, divide 5 plus 4, 9, 9 into 9 parallel to that resistance 12 ohms, 9 into 12 by 9 plus 12. I simplified this, and series to 4 ohms only now. Yes, 4 I can put now. 5 plus 4, 9, 9 parallel to 12, and series to 4 ohms only now. If you are using the calculator, you will get the what now? IY value. That IY comes as 7 amperes again. This comes as 7 amperes only mostly. This comes as 7 amperes if you are using the calculator. Once we got the IY, I2 I can find. But I2 direction and IY direction are opposite only, we can say. While you are calculating the I2, the sign of the current will be taken with what? Minus only. Why minus, sir? Current is in reverse. I2 is opposite to the what now? IY only now. In that case, I can find I2 equal to what? Minus IY. IY means 7 into opposite resistor 12 divided by 5 plus 4, 9 plus 12 only possible. Use calculator. Then its value comes as 4 amperes only. Minus 4 amperes we can get this side. Minus 4 amperes mostly possible. That much current only. Finally, we want to find out the current of I. According to the superposition theorem, you know very well, I1 plus I2 is nothing but I only now. What I1 we are getting already? The value of I1 is 5 amperes. Yes, I will put this as a 5 amperes we are getting. What about I2? I2 is nothing but the minus 4. 5 minus 4, it comes as a 1 ampere only. Yes, the current of 1 ampere is going to pass through the what now? The 5 ohm resistance only now. That way we can do the what now? Problem only now. Whatever the number of what now loops are given, it doesn't matter now. By considering the what now individual sources, we need to calculate required current or required voltage only now. And I wish to give one more problem. One more question I will give now. That becomes a last problem only now. Understand now. The next class I said we are going to do the maximum power transfer theorem by using the independent sources and also with dependent sources also now. Understand my point now? Yes. The next problem is given like this. Find current through 6 ohms. Find current through 6 ohms. Current through 6 ohms for the network given. For the network given. For the network given below. for the network given below. How that network is given, you watch. Here connected with 2 ohm resistor and also connected with one battery here. This is 40 volts. This is 40 volts. This side it is connected with 4 ohm resistor. This is 4 ohm and connected with one more battery here. This voltage is given 44 volts. This is given 44 volts. Here given 6 ohm resistor. This is 6 ohm resistor. Is asking to measure this current I. Yes, that current is required. I'll check the values 40 volts and 2 ohms and 4 ohms and 44 volts, 6 ohms. I is required. Yes. Anybody can find this current directly? I is required here now. How you can determine the current I? How you can find this I? But here also we got the what now, more than one source, one voltage source we got. It is applicable superposition theorem only. Sir, I will not apply superposition theorem, sir. Resistance and what now, source and resistance. Some students will say, if they are having the what now, subject knowledge, means reciprocity theorem also, it's not reciprocity. Millman's theorem also they will apply for this question. Because the resistor and battery, whenever it is given, you can apply the what now, Millman's theorem. When Millman's theorem is applied, means this will be simplified. It comes as a single resistor with a single voltage source. Single resistor with a single voltage source. And connected in series to the 6 ohm. They will calculate 6 current I only now. That is one of the method. Otherwise, they will apply the nodal analysis also. They will select the node voltage V here. This current plus this current plus this current equal to 0. Voltage V you determine. V by 6 is I. One more method. That is also not required, sir. Just apply the Maxwell's loop method. You will get current only now. Any method you can apply. Choice is yours. By using the Millman's, by using the nodal, by using the what now, mesh analysis, by using the what now, superposition theorem. This problem can be done only now. Yes, I am using the superposition theorem only for the time being. How I can apply the superposition theorem here now? You please watch. I selected initially this voltage source, 40 volts I want to consider here now. Solution. I wish to consider this voltage source. I got 2 ohm resistor here that I want to connect as this. I connected 40 volts this side. This is 40 volts. The 4 ohm resistor is connected this side. I will connect as this here now. And this battery must be shorted. This voltage source must be shorted only now. And I wish to connect the 6 ohm this side. I connected 6 ohm resistance only. This current I want to take it as a I1. I want to take it as a I1. But you can find that I1 by any method only now. Any method you can apply and you can determine that current only now. Any method it is applicable only now. By using the any method you can calculate only now. Let's find this one. Anybody can do this? But initially I will find the what the current of this Ix. Once I got the current of Ix, current divider formula I can apply only now. How I can find the Ix? Voltage by 40 volts divided by total resistance in the networks. Sorry. But these 4 and 6 are in parallel. These two are in parallel and series to 2 ohms. 4 into 6, 24 by 10 plus what? 2 ohms only. 2 ohms. 4 into 6, 24 by 10 plus 2 ohms in series. If you are using the calculator, Ix you can get as a, Ix will come as 9.09. 9.09 amperes of current is possible. Once this current you are getting means I1 you can determine by using the current divider formula. What is current divider formula? Ix into, Ix is nothing but 9.09. I can put 9.09 into opposite resistor. Resistance 4 by 4 plus 6, 10. I can put now. So if you use calculator, it comes as a 3.636. 3.636 amperes of current is possible. This is I1, 3.636 amperes of current is possible. Now what we have to do, this voltage source is shorted, this source is to be considered and calculated I2 value only. I can take 2 ohms here connected, yes. There is a 2 ohm resistor. This voltage source I shorted and I got still 2 ohms I have taken, 4 ohms with 44. 4 ohms are given here and also connected with 44 volts only here now. This is 44 volts. And this side connected with one more resistor. That resistance is given in the problem 6 ohms only now. Yes, I will put 6 ohm resistance now. This is 6 ohms only now. We want which current? Sorry, we are in need of which current? Current across, which current is required? I1. Across 6 ohms I want here now. Across 6 ohms I want. This current is I2 only. I want this I2. The circuit is correct or not? I'll check. Let me check this now. 2 ohms and 4 ohms and 44 and 6 ohms correct only now. How we can determine I2? Yes, nodal is the best way to find. By using the nodal analysis, I will find this is the V I have taken now. Once I got this V, I2 is nothing but V by 6 only. Directly you can calculate. How we can apply the nodal analysis? Away from the node, you put the direction. This current plus, this current plus, this current equal to 0 only directly. What is this current? V by 2. I can put directly. What about this current? V minus 44. V minus 44 divided by how much? 4 ohms only. Plus this current is nothing but V by 6 I can put here now. V by 6. Summation of all the currents equal to 0 only. Once again, you please watch. This current is nothing but V by 2. Yes, I have taken V by 2. This current is nothing but V minus 44 by 4. This current is V by 6 only now. Summation of all the currents equal to 0. Then by, you take the LCM of 12. 12 I have taken now. 2, 6, 6V I will get here now. 6V. 4, 3 is 3V I can get now. 3V. Minus 3, 44 is 132 I will get here now. 132 it is possible. Sorry. But here the 4 3s, 3V, 3 4s, 12, 132 I am getting now. These are 6 2s, 2 into V, 2V is mostly possible. That equal to 0 only possible. How many number of V's we are getting now? 6. This is a 9, 11V I am getting here now. This is equal to 132 we can get here now. And finally, V value we can calculate. 132 by, it comes as 132 by 11. 132 by 11, if you are using the calculator, its value comes as a 12. It comes as a 12. Once we get the voltage of V, you can find the I2 value. So I can get I2 equal to what? Voltage by resistance only, V by 6. The V is nothing but 12 volts. Divide by 6. I'm going to get as a what now? 2 amperes of current is possible here now. But I am in need of the what now? Net current I. Current through the what now? 6 ohms I want. When the two sources are connected, two voltage sources are connected, I want to find the current I. I equal to what? I1 plus I2 according to superposition theorem. We know very well. What is the I1 we are getting here? We got I1 as a what now? 3.636. 3.636. And I2 is nothing but the 2 amperes we are getting now. And whenever these two are added, we are going to get I. This becomes a 5.636 amperes of current is going to pass through the circuit only now. I think each and every student might have followed this superposition theorem only now. But I did the number of problems by using the what now? Independent sources and also independent and dependent sources also. In the next class, you are going to see maximum power transfer theorem. Don't miss the class, try to attend this. You will understand the what now? The methodology of doing the problems by using Maxwell's power theorem. Thank you.